We'll be starting in a few minutes. Hello, am I audible? Okay, can someone confirm that I'm audible? Okay, I think I'm audible, yeah, okay. Vishwanath says, thanks for discussing, yeah. Okay, that's good, okay. We'll start the solutions at around 10:10, I guess. We'll wait for a couple of more people to join. Till then, yeah, okay. Okay, I'm audible, okay, that's nice. Okay, yeah, I think we can start for now. If you have any doubts, you can always put it in the chat box. It will be visible for me. But yeah, so starting with how was the contest, I felt that it was a very nice round. There were 8 problems in total. It was a Div 4 contest. I was able to solve all of them in like 34 minutes and I was placed 59th position, which I think is not very bad. But yeah, so now let's keep going. Let's start with the first question. Okay, so the first question was fairly easy, I think. We were given 3 digits A, B and C, and the question is whether we can choose any 2 digits to make a sum greater than or equal to 10. So what will be a simple algorithm for this? Simple algorithm would just be the 3 digits are A, B and C. Let's sort them and check if, like, essentially the largest plus the second largest is greater than 10. So if the answer to this question is yes, then we output yes, and if the answer is no, we output no, right? I think that's a very simple question. Hopefully that's clear. Okay, yeah, okay, right. So I think the first question is fine. Okay, let's move on to the next question. So problem B, okay, problem was like 10 words of wisdom. So let's see what the problem is about. So there are n participants here, and each participant submits some response, and there is some response and some quality. We're saying that all the responses have like distinct qualities, and at least one response has length more than 10. So now we are saying the winner of the show is the response which is the highest quality, but its length should be smaller than 10. So like what will be a simple algorithm for this? Let's think about this. Okay. Oh, in the chat box, some people are saying to skip the question. I'm not doing that since like some people might want to have a solution. So I'll just quickly explain it. Shouldn't take more than a couple of minutes. So for B, we are given various values of A and B, right? So think about here is A is the number of words and B is the quality. So we want B like A to be smaller than 10 basically, because it shouldn't be longer than 10 words. So if A is less than or equal to 10. So whenever A is less than or equal to 10, for that we find the maximum value of B. And like that's basically my solution. So I'll quickly show you my code also for this. Like it's just like take inputs and we're just checking if it's smaller than 10. If it's smaller, we're just finding that corresponding index where the value of B is the largest. So hopefully that's clear, right? I am moving on to the next question, the C question. Okay, so people ask question 3, yeah. Right, so we are given an 8 by 8 grid of dots, and the question is, how do you find the word that's written? No, there are many ways to do this, so let's see how we can do this. But I think one way would be the easiest. That's just my personal opinion. So we are given some 8 by 8 grid like this, right? And we are given some word that is hidden somewhere over here. Now, one interesting thing which I noticed was, like let's just iterate over like all the possible words, right? Turns out the desired word that will be in sorted order. Like if I just choose all the characters which are not dots, it just be in sorted order. Like I'll give an example. I'll take A and B here, and I'll have a bunch of dots over here. So if I just like iterate over all the positions, and if I just like try to basically output like the corresponding string, like if I just ignore all the dots and I print all the other characters, I should just get my string itself. So that's basically what I did. I just iterated over like all the possible dots. I iterated over these dots. None of them are characters, so we are good. I iterated over these things. A was a character, so I just outputted A. Next B was a character, so I outputted B. So my final word is AB. So does that make sense? So that was my my implementation. So word on the paper. So I'll quickly show you my code also. Okay, so I just took like a bunch of strings as the input. I had a string called answer, and to that I just appended all the characters which are not a dot basically, and I just outputted that at the end. So hopefully that's clear, right? Okay, let's keep going. Oh, any doubts on this question? Okay, hopefully. Okay, okay. Someone has asked, what is the rating of problem D? I'll quickly show that also. So I think problem D was like doable only. It's not very hard, I felt. So probably would have been like 1100-ish, I think. Yeah. Oh yeah. Wait. Yeah, I can see the chat here. I'm able to see the chat here. So problem D was like 1100-ish, I think. It's not very like it's not too hard, but yeah. Right. So problem D was essentially, I'll explain the problem. You are given essentially a bunch of elements, and like we are given a bunch of problems, and each of them have a difficulty. So we can remove a bunch of problems and we can rearrange the problems, and we want to check if a round is balanced or not. And how can we do that? So the first thing is we are allowed to rearrange the problems. So let's just sort the given array, right? So since we are given some array, first thing I'll do is just sort the array, because we are allowed to rearrange the problems. Now I'll take a test case as example. So I'll take 1, 2, 4, 5, 6. Here notice that k equals 1. Okay. Now what is the most important thing to notice here? If you think about this, between these two the difference is 1, so we can select this subarray essentially. We can select this subarray also, because all of them have a difference of 1 between them. But the thing is, we cannot select this entire array, because then the difference between 2 and 4 is 2, so that won't be suitable. So that's one interesting thing to note. So what will be a solution? So let's think about the solution, right? We can always divide our array into a bunch of subarrays like this. Okay. Now within each of these subarrays, the difference between consecutive elements would be smaller than a k, essentially smaller than or equal to k in each of the subarrays. But if you choose any two like different subarrays, then the difference between consecutive elements may be greater than k also. Now let's look at the lengths of these things. So the length of this is let's say like some 4, length is 5, let's say length is 3 and length is 2. I will just greedily choose the longest subarray basically, and I'll get rid of all the other subarrays, and actually that's the optimal solution. So what is the optimal solution? Optimal solution is first to sort the array. After we are done sorting the array, we essentially divided it into pieces, like essentially subsegments, which the consecutive elements have a difference smaller than k. So now we have a bunch of subarrays. After we have a bunch of subarrays, we find the longest contiguous subarray that has a difference less than k. So that was my idea. Does it sound good? Any doubts on the question? Okay. So offline is asking me to explain a question again. Can you tell me which question you want? I'm not very sure. But yeah. Okay. Okay. So okay. We have a couple of interesting things in the chat box about G problem. Okay. So I'll show you my implementation for D also. Let's see how that works. So like I just took in the array as input. I sorted my array as I explained. So after that I have an like variable called current basically. That current is how big the current subarray is. Now if ai plus 1 minus ai is bigger than k, that means we have to essentially create a new subarray. Like we have to break the previous subarray and we have to make a new one. So that means I'm setting current equals 1. Otherwise I'm just incrementing this variable called current. And I'm setting answer equals maximum of answer comma current. That's because answer is my final answer which I want. I'm just setting it to be the maximum. And like I'm doing one more answer equals max of answer comma current here, because essentially like the last subarray which you have, like this subarray that might not be like initially updated. Since that last subarray is not updated, like we are doing answer equals max of answer comma current. And in the end I'm just outputting all the elements I have to delete. That is essentially the total length of the array minus the length of the longest subarray. So does it make sense? Okay. So we have a couple of interesting things in the thing. Okay. Okay. Someone is saying they didn't understand the problem D, so I'll explain. So what did we do? I'll take a different test case as example also. So I'll take this big test case here. We'll see what happens. Okay. So first thing was we are sorting the array, right? So it's just 1, 3, 5, and then it's like 12, 17, 17. Oh wait, there are two 12s. So it's 12, 12, 13, 17, and 20, right? And of course, k is given to be 3. So my solution was we sorted this. Let's find all the contiguous subarrays for which the difference between consecutive elements is smaller than 3. So this is one valid subarray, this is one valid subarray, and this is one valid subarray. Why is that? Because the difference between 1 and 3 is 2, so that's fine. This between 3 and 5 is 2, that's fine. This difference between 5 and 12 is 7, so that is not valid, so we have to break that for sure. So we just keep doing that. So we have 3 different pieces here, and we just greedily choose the largest such subarray. So does that make sense? Okay. Yeah. Okay. So hopefully that's fine. Yeah. Okay. So that's the basic algorithm. If there are no doubts, I'll keep moving to problem E. Okay. Yeah. So problem E was, I mean, you can have a look at the question. I'll pause for a minute if you haven't tried to solve it already. Okay, so E, someone suggested quadratic equation formula. Actually, that's correct only. So I'll tell you my solution for this. So E question was like, essentially we're given a bunch of squares, and around the square there is some border of like width W, and we're given the total area, and question is how to solve this. Okay. So first of all, let's think about this. I have one square which has side some, let's say alpha, right? So I have a square of side alpha, and surrounding it I have a border of width W. Now, like what is the total area of this? Is actually alpha plus 2W squared, right? So the total area of this particular piece is alpha plus 2W squared. Alpha plus 2W the whole squared, right? Because like essentially this is alpha plus 2W. So hopefully that makes sense. That the area of one square with its borders is alpha plus 2W the whole squared. Now we are given a bunch of side lengths like this, so that will just be this thing summed over all possible alphas. Okay, so we just take the sum over all possible alphas. I can also expand this, so this like alpha squared plus 4 omega times summation of all alphas plus let's see, plus 4W squared. Okay, and we know that this is equal to C. C is the sum of like all of these areas, so that's equal to C. So this is the equation which I have. So let me rewrite this in a better form. It will be like 4W squared plus 4W summation of alpha plus summation of alpha squared minus C equals 0. Okay, wait, someone in the chat box is asking me to show submission for D. I'll do that after this question. Yeah. Okay, anyways, moving back to this question. So we have this formula kind of here, where the quadratic formula. So what will be the correct value of W? W will be minus 4 summation of alpha plus, or like we just take the positive root, because I mean it has to be the positive root. B squared is just 16 times sum of alpha minus 4 times summation of alpha squared minus C times 4. Wait, actually I did a small mistake here. So when you sum like 4 omega squared over this, there will be a factor of n over here, and there will be a factor of like that's it. So there will just be a factor of like n over here. So this should be actually 4n omega square, 4n W squared. So this is just a small typo I made. Hopefully that's fine. Yeah, okay. This times 4n, and we're dividing this entire thing by essentially 8n, right? So hopefully this is fine. Okay. Yeah. Okay. So this is W here. This expression for W we got here. So we know all of these things. We know what is n. We know what is like summation of alpha squared, and we know like what is summation of alpha also. So this should be pretty easy to calculate. So that was basically my algorithm for finding what is W. You can do binary search also, like just binary search over the correct value of W, but I guess this was a bit easier to implement. So I'll show you my solution for this. I'll zoom this up a bit also, but yeah, right. So I've also made them floats. I made them floats because it's a bit easier to like essentially take square roots and stuff like that. If you're working with floats, you can do this with an integer also, but that might lead to some errors. So I'm just using floats here. Also, I have hashtag define float long double in my template. That means all my floats are redefined to long doubles, and so like long doubles are more precise than floats, so I can always use long doubles. Anyways, so I've defined my sum to be equal to 0, and ARSQ is the sum of all the squares. So I'm just taking all the A's as input. I'm just like finding the sum of all the numbers, and like finding the sum of squares of all the numbers. Then I'm just directly putting it in the quadratic formula over here. Like as I explained, I'm just directly putting it in the quadratic formula, and I'm just outputting the value of W. So does that sound good? Yeah. So I hope that was clear. Okay. Oh, wait, did I mess something up? Yeah. So Shivam was asking whether it will overflow in int. Yeah. So I've defined my int to be a long. So I guess I didn't mention that. In my template, my int is defined to a long. So all my ints are longs by default. So hopefully that solves your question. Okay. Someone asked my D solution also. I'll quickly show that. So this is my D solution. Someone in the chat box asked. You can like pause the video and like take a screenshot or something. Maybe that might be easier. Yeah. Okay. Okay, right. Okay, people are saying it's clear. Okay, that's good. So someone is saying D was like the magnets problem. I'm not exactly sure what is the magnets problem, but yeah, right. Okay, let's keep going. So we'll have a look at problem F. Okay. So problem F is also pretty interesting. Problem is like Mihir and Slavik, we are looking at a group of n frogs, and they are numbered from 1 to n, all initially at 0.0. And the question is, each second, frog I hops a units forward. Like we want to know what is the place where you like keep a trap so that maximum number of frogs can like fall through that point. So hopefully the question is clear. So problem F, I'll like try to explain the question. So we are given some like positions from like this, and the frogs keep hopping. Now notice that we can keep a trap only from 1 to n. So 1 to n, like this is some position 0. So what the frogs do is, depending upon their values of ai, they keep jumping like this. Okay. So in this case, a is equal to 2. If a was 3, they will be jumping something like this, like this. Okay. So like that's the basic idea here. So let's rephrase the problem. Okay. So let's say my correct answer was at some index ind. So if it was at some index ind, I essentially want to find the maximum of like essentially the maximum of ind. Ind goes from 1 up to n, such that ind is divisible by 8. So essentially we want to find the position which is divisible by the most number of ai. Because if you think about this, if a frog can jump, let's say a1 units, then all the positions it visits are a1, 2a1, 3a1, 4a1, etc. Right? So basically it visits all ka1. That means we want to find the position which is divisible by the most number of frog hops. Like that position should be between 1 to n, and we want to find the position such that it's divisible by the most number of frogs. So that's like the basic idea here. Now that is just the basic idea, but let's see how we can do the implementation. So like we have a couple of ideas here. So before that, one thing if you didn't know already, I'll quickly show that here. So if you do something like 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 all the way up to 1 by n, this is approximately log of n. Like this is using some harmonic series kind of. We'll need this while we are figuring out the time complexity. So like just keep this in mind. So like there are a couple of algorithms to solve this. If you use something like a sieve, that might not be very appropriate because that will TLE. So instead what we can do is basically we'll just iterate over all the desired positions. So I'll explain. We have some A1, right? So we'll just keep iterating for all of the various possibilities. Like we'll just iterate from A1, 2A1, 3A1, 4A1, all the way till we reach n. Like till we reach number greater than n, we just keep checking A1, 2A1, 3A1, 4A1, etc. all the way till we reach n. Now, what will be the time complexity of all of this? That will be something like n by A1 plus n by A2 plus n by A3 plus n by A4 all the way up to n by an, right? So the time complexity of this is this thing. Now let's think about what might be an expression for n by a1 plus n by a2 like that. So if all the a1s were 1, so if all of them are 1, then actually this will be O of n squared, right? This will be O of n squared, and that will lead to TLE. So if all the a1s are something like 1, then we'll definitely get a TLE. But what is the correct solution then? Well, the correct solution is actually to maintain a map of all the desired positions. So if we maintain a map of all the AIs, so I'll just maintain a or map or frequency array, like anything works, it doesn't matter. So map and frequency array are like interchangeable here. So we'll just count how many times each AI occurs. Okay. So if let's say a, like let's say some value of a, let's say some a3 or something, that occurs 4 times. If it occurs 4 times, like for that particular position, the number of like places where it will occur is actually 4 times n by a3, right? And this 4 is a constant factor, it doesn't really matter. So the point I'm trying to make here is that so this expression n by a1 plus n by a2 all the way up to n by an, instead there is actually a simpler essentially version of this. This simpler version is something like n by ai, but actually we are just summing over unique ai. And if you are summing over unique ai, then we definitely know that this is, in the worst case scenario, this is like O of n by 1 plus n by 2 all the way up to n by n, and by the harmonic something I told you, this is approximately O of n log n. So that's the proof that this works. So I think it's a lot to take in. It's not exactly an easy algorithm, but hopefully that was clear. Any doubts? Okay, it's a harmonic progression sum here. Okay, hopefully that is clear. Okay, let's keep going. So the idea for f was, I'll quickly go through it again. We just maintain essentially some kind of frequency array of how many times each position occurs. Like if I show you my implementation, it might be a bit easier to see. Okay, so I mean I just called it a DP array because it's kind of like dynamic programming, but I mean you can call it whatever you want. The point is, I'm just like essentially iterating over all the possible positions, and like I'm just taking in all the AS as input here. I'm just putting it in the map as I explained. Now, now what I'm doing is, I'm like just doing a for loop for all my indices in the map. I'm just doing like j goes from 1 all the way up to n plus 1. I'm just doing a dp of j times I dot first. So this will increment all the positions like a1, 2a1, 3a1, 4a1, etc. But it will increment those positions by how many times it occurs, because essentially that many times it will be increased. And in the end, I'm just taking the maximum of all of these things. So like I'm just taking answer equals maximum all of these positions, and I'm just outputting answer over here. So hopefully that's somewhat clear. Yeah. Okay, so Shivam is saying, okay, Shivam came pretty close, I guess. Okay, that's good. Okay, yeah, so hopefully my algorithm is clear. Okay, yeah, okay, if the algorithm is clear, I can keep going, I think. I'll move on to problem G. Okay, problem G was also pretty interesting, I think. So, like, I'll explain the question to you. I think that will be a bit easier. So, we are given a bunch of points. So, like, I'll just make it a bit bigger. Yeah. Okay. So, we are given a bunch of points, and the question is, like, question says something, but we can like rephrase the question this way. I will choose one compass and one morning star. So I will choose one of the points to be a compass. I will choose one of the points to be a morning star. And actually, like the compass points towards the morning star. So this has to like either point, like it should point to one of the 8 cardinal directions. It can't point anywhere else. So am I being clear in that? Okay. Yeah. Okay. Ashutosh is asking what are the prerequisites for G and H. Like for like the prerequisites for G and H, like not many prerequisites as such. I think G doesn't have any prerequisites. H might have a few prerequisites, but yeah, H is like graph theory based. Okay. Anyways, so essentially we have like a lot of points. In the lot of points, like we have to figure out. Like we have to choose one compass, we have to choose one morning star, such that the morning star is in like a particular direction from the compass. So I'll start with a simpler case. Like we'll try to find how many north, south. Like assume the compass can point only to the north or south, and we calculate how many such positions are there. So I'll draw a couple of points here. Okay, so you can think about the answer here. But like what will be the answer here? Let's think about this. The compass can only point to the north or the south. That means basically I can choose, like we only care about like the x coordinate. Like as long as the x coordinate is the same for all of these points, the x coordinate is the same. If the x coordinate is the same, then actually we can choose the compass and the morning star to be any two of these things. Like compass can be like anywhere, and morning can be like somewhere else. Like one of these has to be C, and somewhere else it has to be M. Likewise, C has to be somewhere and M has to be somewhere. So here C has like essentially 3 possibilities and M has 2 possibilities. Here C has 2 possibilities and M has 1 possibility. Okay. So for this particular case, the answer is 8 actually. But so if you think about what will be the answer will just be, we'll keep track of how many positions are there in each x index, like for how many points the x coordinate is the same, for all the points for which the x coordinate is the same. Okay, let's say if your x coordinate is some alpha and there are beta such points. So alpha is x coordinate itself, beta is the number of such points. From this, the number of valid combinations is actually beta times beta minus 1. It's beta minus 1 because essentially the morning star can't be at the same place as the compass, so it's beta times beta minus 1. So hopefully that thing is clear. Yeah. Okay. So like what will be the final answer here? So what we can do is we can just maintain a map. So the map will be x coordinate and how many times it occurs, and we'll just like basically iterate over the map, and the answer will be like this thing times this minus 1 summed over all the x coordinates. So hopefully that's clear. Now obviously you should be clear that you can do the same thing for like if you want to do east/west, this thing would be true for all, like basically we would be doing the same thing for y coordinates. Okay, so we'll do the same thing for all the y coordinates. Now if it is northeast or southwest, then what do we do? Let's think about this. One point is over here, one point is over here. So a couple of points are like this. We are caring about only the northeast or southwest direction. So actually in this case what will happen is, if you look at what will be constant here, they all pass through the line x plus y equals c. Wait, is that correct? Like I guess it should be x minus y is equal to c, or yeah. So basically if like a few points they are like in the northeast or the southwest of each other, they all pass through the line x minus y equals c. So basically we will just keep track of all the x minus y values in a map. So here it will be actually a map of x minus y, and we'll just count how many times it occurs, and again we'll sum it over as I explained the same thing. Likewise, if you want north, west or southeast, then it will be basically a map of x plus y, because they all pass through the line x plus y equals c, and we do the same thing again. So is that clear? Okay. Okay. So, Chanukya wants me to. So someone is saying y equals x for northeast, southeast. Y equals x is only if it passes through the origin. In general, it can be y equals x plus c, and y equals minus x plus c. Yeah. Okay. Yeah. Chanukya is asking how you explain G using a test case. I'll do that right now. So the first case was 0, 0, minus 1, and 1, 1. So I'll plot all of that. 0, 0 is over here, minus 1 is over here, and 1, 1 is over here. Okay. So if you think about this particular test case, all of them pass through the line y equals x plus like y equals x, right? So since they pass through the line y equals x, I can choose compass to be over here, morning star to be over here, or like I can choose compass here, morning star here, or compass here and morning star here, or compass here and morning star here, or like basically I can choose this in like 3p2 ways basically, or 3 times 2 ways. I can choose compass to be anywhere, morning star to be somewhere else. So for this case the answer is 6 actually. Yeah. Okay. Hopefully that's clear. Okay. Yeah. I'll quickly show my implementation also. So if you look at my implementation, I'm just having 4 different maps here. I have a map called x and y. xpy is for x plus y, and xmy is for x minus y. I guess technically we could have used a frequency array or something also, but like, like I guess we can't use a frequency array because all the x and y coordinates are too big. But a map should work. So I'm just keeping track of all the positions where x plus y and x minus y is the same. I'm just throwing all of it into a map. After that, I'm initializing a variable called answer. I'm just doing like for everything in the maps, I'm just doing I dot second times I dot second minus 1, and I'm just outputting that answer over here. So I think the implementation is fairly easy, I think. So and like an O of n squared algorithm might not work clearly. Yeah. Okay. So like brute force algorithm of n squared will get DL. So hopefully that's clear. Okay. Okay. Someone is saying it might be easy by first look, but to solve it, O of n log n. Yeah, I mean, yeah, it's not like it might take a while for you to get the answer. I guess that's fine. But okay, let's keep going. Problem H was a graph problem. Like I'm not sure if there's easier solution, but I did a graph problem at least. So like the question was this. So like essentially Mircea wants to like has a bunch of soldiers basically. They're arranged in different camps. There's only one soldier in each camp, and there is one camp in all of the integer points. And there is some strategies. So strategy is like A should belong to a camp that is situated DI meters in front of the camp that person BI belongs to. Okay. So I'll try to explain this. Like, by the way, if you haven't seen graphs before, it might be a bit difficult also. Not very sure, but yeah, right. So let's take a example of AI, BI and DI. I'll take A1, B1 and D1. So we have a number line like this, okay, and the condition is like soldier A1 should belong to a camp that is situated DA meters in front of BI. So basically, if B1 is over here and A1 is over here, this distance has to be D1. Okay. Now, if you had a bunch of test cases like this, let's see how we can do that. So like, let's say B1 might be over here, like A1 might be over here, and like D1 might be over here. And like after that, you might have one more condition in which okay, I'll give some examples to make it a bit easier. So I'll draw a number line here, and in this number line, I'll take the cases 1. I'll take the following values of A, B, and D. I'll take let's say B to be 1 in all the cases. I'll take something like this. Make this 2. I'll make this 3. I'll make this 4. I'll make this like 5 by 4 maybe. I'll make this 5, and I'll make this 3 maybe. That should work. Okay. Okay. So now let's see what happens. So like one thing you might notice is you can place like the first soldier anywhere without any loss of generality. You can like essentially shift the position of all the soldiers. Like you can shift the origin without any issues. So since we can shift the origin, I'm just arbitrarily placing the first soldier at 0. So the first soldier, I'll just draw a nice number line here. I don't think any negative indices, so I'll just stick to positive indices. Okay, so we have a number line like this. I'll place soldier 0, like soldier 1 at the 0 position. So the soldier 1 is over here. Now where can we put soldier 2? Soldier 2 is like 4 units in front of 1, so soldier 2 has to go here. Where will soldier 3 go? Soldier 3 has to be 5 positions in front of 1, so soldier 3 has to go somewhere over here. Soldier 4 has to be 3 indices in front of 2, so soldier 4 has to go somewhere over here. So is this test case clear? Okay, I'm assuming it's clear. So let's keep going. So now like this is the various conditions here, but let's think about something else, right? So if instead of this, if I had something like something that was essentially contradicting. So let's think about this. If I had one more thing like this, right? 1, 5, 1, 4, and let's say 2, right? So this condition states that 4 should be 2 units in front of 1, so 4 should be over here, right? But actually that is invalid because 4 can't be both here and here. So in this case the answer is no. So essentially what is our problem? Our problem is to check if there are any contradictions. So if there are no contradictions, then we are good. But if there is some contradiction that says like 4 is at 2 places or something like that, then we have problems. So hopefully that's clear. Okay. So like basically the idea is to check for contradictions. That's one way to put it. You can do that using graph theory. So like if you haven't seen graph theory before, don't worry too much about it. But if you have seen it before, like it's a good thing definitely. So in my implementation, I can tell you what I did. So first thing, I created an adjacency list. So like first of all, to explain why there's the graph theory problem, essentially what we can do is we can keep a graph which essentially keeps track of all the various indices and the corresponding relations. So it will be something like this. So I'll have 1 here, I'll have, let's say, wait, I'll draw it here. So I'll have 1 here, like I'm drawing it for the about this case. 1 is over here, 2 is over here, 3 is over here, and 4 is over here. So the distance between 1 and 2 is like 4 units. So like here we can have an edge basically that says this is like 4 units. Distance between 1 and 3 is 5 units, so I'll keep track of that also. Distance between 2 and 4 is 3 units, so this is basically 3 units. Okay. And stuff like that. Oh, by the way, this is negative also. Negative means it's in the backward direction. So hopefully that's clear. No doubts in that, I think. That should be fairly easy to understand. So I'm just checking all the various distances here. So like let's see what we can do about this. For each index, I'm just counting how many other indices are essentially like attached to it. If you haven't heard the term before, that's called an adjacency list. So like I just have various edges like this, and actually in this above case from 1 to 4 there's an edge of length 2, which doesn't make sense. It doesn't make sense because it's a contradiction basically. So if I were to explain my algorithm to you, I will just show the implementation. I think that's a bit easier to explain. So as I told you, I have essentially an adjacency list. It's not an adjacency list. Basically, it's a vector of pairs. So like it's a vector of pairs because I have to keep track of both the node it's connected to and what distance it is. So that's why like it's a vector of pairs. So after that I'm just taking like I'm making this adjacency list. After that, what am I doing? I am initializing this array called distances. Now if you think about this, like in the distances I am just storing the relative distances basically. Okay, I'll think about it, give me a second. Okay, so we're just checking for contradiction, right? So I just have this array called distances basically, and I'm just running a simple DFS here. I also have an like essentially a vector of bool's called visited that keeps track of whether you visited a particular node or not. I also have a variable called flag. I'll explain what the flag variable does in a while. So if a node is already visited, we don't bother with it, so we just continue. Otherwise, I'm just running DFS. If I'm running DFS, as I told you, I'm checking for a contradiction. So like whatever graph we have, we'll firstly assume it's connected. It doesn't need to be connected, but let us for now assume it's connected. So it will be something like this: every component is connected. For now, let's stick with the assumption, and then explain what happens if it's not connected. I'm just setting visited of node is equal to true. I'm just iterating on all of its children. Now, if you haven't visited its child, like if you haven't visited one of its particular children, that means its distance would not have been assigned before. Like if you haven't visited a particular child, that means its distance hasn't been assigned before, so you can assign it to something. You can assign it to basically the distance of the node plus like the value of d basically, and I'm just running DFS from the child node. But if the distance had been assigned before, if you have visited a node, like the simple idea is if you have visited a node before, then its distance will be known for sure. And if you know its distance, we're just checking if distance of child dot first is not equal to distance of node plus child dot second. Basically, if they're equal, we are good. But if they're not equal, I'm setting this variable called flag equal to 0. So essentially, flag variable keeps track of whether this is possible or not. Now, if flag is equal to 0, then I'm just basically returning. So hopefully that's clear. Okay. So yeah. So like if flag is like 1, I'm just outputting yes, and if flag is 0, I'm outputting no. But of course, the thing is, we're not given that the graph is connected, right? So what do you do if the graph is not connected? The advantage is basically our camp is like infinite. So our camp is infinitely big. What we can do is we can place all the components here, like all connected components here, and then we separately place all the like after all of these indices get over, you can place all the remaining connected components somewhere else, etc. Since the number line is infinitely big, we can just like keep putting them like one after the other, so it doesn't really matter whether they're connected or not. So I'm just running this individually for each of the connected components. So hopefully that's clear. Yeah. Okay. I think like it's not exactly a very easy question, so hopefully that was clear. But yeah, right. Okay. So I'll explain my implementation once again. So like I have some like I have some like 2D vector of pairs basically. In that I'm keeping track of like essentially an index. Oh, also I have this minus d here because like if we know a distance from A to B, we know the corresponding reverse distance also, so we're essentially checking that also. And then I just initialize all the distances here. Then I'm just like doing DFS for each connected component. So for one connected components, I'm doing it over here, and then like here I have the DFS thing basically, and we're just checking if it's visited or not. If it hasn't been visited before, we just visit it anyways, and we're just setting distance of child dot first equals distance dot node plus child dot second, and otherwise we are outputting like if it doesn't follow that and there's some contradiction, we're setting flag equals 0. Otherwise we are not changing flag here. If the flag variable was 0, we're just outputting S here. Otherwise we are outputting no. So is that fine? Hopefully this is clear. This will be like O of M, I guess. Yeah, you can do it in O of M, I guess. So hopefully that's clear. Yeah, okay. I think that's it for today. Yeah, so Vishwanath is saying thank you for session. Yeah, hopefully you had fun. And like make sure that you subscribe, and if you have any doubts you can put it in the chat box. But I think that's it for now. So I think we can end this stream. Okay, I'll end this stream for now. If you have any doubts you can always ask it later in the comment section. But yeah, thank you for watching.